Good morning, good afternoon, good evening, depending on where you are in the world. Today is episode number 34 and a very Merry Christmas episode, if I may say so, of the Unboxing AI webinar series. Thank you for joining. Wherever you are, we have a very, very special guest with us today. For those of you who don't know, Unboxing AI webinar series, this happens every Friday, 11 a.m. Eastern. Although we are now contemplating changing the Friday, but more on that later. And by CARPL, CARPL is, I say it all the time, your friendly neighborhood imaging AI platform, helping you navigate this entire ecosystem of hundreds of AI developers on one side and, risk PACS integrations on the other. We sit in the middle helping radiologists, CIOs, CMIOs build, test, deploy, and monitor AI in clinical workflows. So with that, it gives me extreme pleasure and it's an honor for me to introduce Sham. Sham Sokka is the Chief Operating and Technology Officer at DeepHealth. Again, I'm sure many folks would know DeepHealth is the informatics AI technology division of RadNet, and the largest outpatient imaging provider in the world. In fact, I think with 400 centers. And with Sham, with more than 20 years of executive experience, has held leadership roles, including senior vice president, head of innovation excellence, and head of marketing as well. In fact, at Philips Precision Diagnostics Business Cluster, essentially Philips for those. His his expertise spans across informatics, healthcare analytics, cocktail development, engineering, and global marketing. And of course, he's able to make good cocktails because he holds a PhD from the MIT Harvard Division of Health Sciences and Technology. Thank you, Sham, for doing this. It means the world.
Yeah, happy to be here and join you guys and talk everything, talk AI
Yeah.
life.
No,
Definitely.
so and for those of you who are here, feel free to ask questions. We prioritize, your questions over our own conversations. So feel free to, use the chat box, use the Q&A, you can WhatsApp either of us, whatever works. So Sham, tell me, you know how many people did you manage at Philips, and how many people is it at DeepHealth, and what does that transition look like, going from
Yeah,
one of the world's biggest companies to a startup within, of course, a very large company.
yeah,
How does that happen, and what does it feel like?
yeah. Look, it's been an interesting experience. I think Philips is a large scale company, probably a order of magnitude difference of number of people that I managed in Philips versus what I now manage at Deep Health. But I think the way I look at it, healthcare. I'm a lifelong healthcare guy, even more a lifelong imaging and diagnostics guy or imaging based therapy guy. And what it's been really interesting is how do you influence the industry, from different perspectives. And Philips
Mm.
was one way to impact the industry because it's very large global organization that has an opportunity to impact millions, billions of lives, right? But in a kind of a broad way. And I think what Deep Health allows me to do is, maybe not have the billions impact, but still have millions impact, but in a very deep way, right? And also coming from the provider side. So it's, you kind of, there's a role for big OEMs in the industry. There's a role for, scale ups like what Deep Health really is. And then there's a role of a provider. And there are probably other couple of types, but it's kind of been fun to sort of see the way you can impact the industry. And I think maybe for me, this recent phase has been really exciting because it's both impacting the industry from the provider space in the last mile of care, as well as deep in the radiology domain with what DeepHealth is doing, with a very specific area of solutions.
So would it be right to say, Sham, that because every decision, or not every, but because decisions you took at Philips could potentially impact billions of lives, uh, you're able to take like what may seem more risky decisions here or more forward-looking decisions here at Deep Health,
Yeah,
or take more decisions, just the frequency of decision. Like how does that uh,
yeah. So the
transition
difference
happen?
is both companies are very innovative. The difference is that you have to steer a tanker, at a company like Philips, to make a change, a course change. And in a place like Deep Health or even RadNet, we can make very rapid changes, I mean, completely directional changes. And and I think I've told you this before, Vidur. I think we're in a time period which is a high level of external market change driven by technology than, let's say, the past 20 years combined. You know, and I think that requires this more nimble organization to have impact, right?
Interesting.
Than the big organizations, right? Where, something like scaling up an MR. I always think about MR as an example. I mean, who on God's earth would think we're going to take a superconducting magnet, we're going to make these things at high scale, and you're going to be able to see tissue, deep tissue resolve, that requires sort of like big, almost like moonshot kind of, innovation energy, right? And that's why the big companies like GE, Siemens, Philips, really succeeded in that era of innovation. If you look at now, where the technology is flooded into the market, right? And now it's about how do I take that base technology and tune it for our industry, right? You need a more nimble setup.
So Sham, tell me one thing, and I'm going to go off script as I
Yeah,
often do.
of course.
You know, GE, Philips, Siemens, were big companies when MR was coming about as well, right? Like it's not that they were small companies at that time, but they still managed to move fast enough and innovate fast enough to now have, what maybe like tens of thousands of MRs installed all over the
Yeah,
world, right?
yeah,
And I have seen an MRI factory, and I think it is the epitome of physics and
yeah,
engineering
yeah,
and anything at all that can, like, I don't know, maybe rocket ships are truly the only thing that are
yeah,
more complicated than that,
yeah.
right? So why are they not able to, or are they doing AI and we just don't see it? Like
Well,
why is the startup ecosystem even needed
yeah.
for AI?
Well, I think they, of course, they're doing AI, right? But
Yeah.
business dynamics, and innovation dynamics, and then the fact that you have, investors to answer to and so forth, require you to focus on innovation adjacent, super adjacent to your primary pillars. So you see AI, for example, from all the big OEMs on, how do I make a better image? How do I accelerate the image? Because they have lock-in, they have capability there, right? But now you take something that's a completely disruptive thing, like we're really talking about, see, the core of a GE Philips Siemens in this space has been historically the device to do the image, right? What we're now
Yeah.
talking about in the AI era is completely changing the doctor machine interface,
Mm.
which is a totally different thing,
Yeah.
right? It really is. I mean, and so the gap is so different and so big
Yeah.
that you
It's like
need.
one could imagine, like, well, like Philips making contrast, for example.
Yeah,
GE does
yeah,
it, so it's not a very
yeah,
good example, but like Siemens making contrast. Like it may be
yeah,
helpful to your product or to your customer, maybe you have the same customer, but technologically it's just so different. And that's where, Sham, like and then we'll move on. But maybe, I don't know if you how closely you've looked at United Imaging. but
Yeah.
they've kind of divided themselves into these two companies, right? One is United Imaging, the device company, and then there's United Imaging Intelligence. That is a separate kind of AI software company,
Yeah.
separate structure, separate leadership, separate everything. And their job is not to sell big iron, right? It's to
Yeah. Yeah.
build technology to either support them or sell independently. Do you think that, like, is that
Well,
the right?
the point that is sort of really different here is, I think a technology push up approach still works on the medical device because it's all about the medical device. What I mean by that is the
Mhm.
image device, right? If you think about where we're going with AI, PACS, the fusion of AI and PACS and so forth, that's about the human.
Yeah,
Because what
I
you're
get it.
really doing is you're augmenting the human. And
Mhm.
and that's also why informatics is so difficult. Everybody thinks it's software and hardware. That's such a fallacy. It's really about technology push versus human centered, right? And informatics, forever is human centric. And that's why, for example, why Epic is all over the place in the US and not anywhere in Europe, right? Because the human behaves differently in
Yeah,
these conditions. And so the software doesn't translate or the informatics
yeah,
doesn't translate, right? That's why you have such a
interesting.
fragmented market in informatics.
Yeah, the job of the MRI machine is to produce a pristine image. The job of an informatics company is to help the user become as fast as they can, right?
That's
Very
right.
different
In their work,
jobs.
in the local workflow, right?
Yeah,
The
yeah,
local workflow is different, right?
yeah,
So it's all
yeah,
about the human. And that's why, until you kind of make the flip, it's very hard. And that's why being at RadNet is super interesting because we're a human business,
yeah, yeah, yeah.
you
You
know?
have your own humans
Yeah,
to kind
we have
of experiment
our own
with.
humans. Yeah, yeah,
I can see a couple of them on the webinar. But yeah.
yeah, yeah,
No, this is
yeah,
this is this
exactly.
is this is really really fascinating. And I don't think uh which is why like PACS is such a natural segue to doing AI as opposed to of course
Yeah,
there is on-device AI. I know you're
yeah,
doing it
yeah,
as
yeah,
well, but interesting. So how does any conversation about AI is like incomplete without your take on foundational AI
yeah,
and visual language models, and like how have the last 2 years fundamentally, or have the last 2 years
yeah,
fundamentally changed what AI can do from a capability perspective,
yeah,
and how, like, if I was you know like time if I time traveled like from 2020, say I'll make it 4 years, right? 2020 to 2024 overnight, like what would be different?
yeah. Look, uh, I think most people know, I may be stating the obvious. We are, we are in the greatest um, uh, um, technology, revolution period, since atomic physics, right? In my view,
Wow.
I really believe that, right? And because the base technology, in that case, the base science, is allowing us to think very differently about problems, right? And that's exactly what's happening now, right? The base technology is making, really allowing us to think very differently about problems. And this is where the foundation models, right? If we look at the evolution of AI, it always required a data scientist, a complex engineering team, etc. And in the end, and compute you didn't have, and there were so many moats, right, to build this, AGI, which is a lot of people are going after, right? Artificial generative intelligence, general intelligence. I think if you now look at where we are today, we've solved the compute problems. We've solved, the data. In fact, the most progressive models have consumed, you know, more data than they've consumed more data than that's left, right? So
Yeah.
they've consumed, so much data now that there's not enough data to make them any better, right? That's kind of crazy, right? And then you have now you can take these now base models, and it's now more democratized in the sense that two guys in a garage
Yeah.
can build a world-class, AI for a certain use case. And so what foundation models are essentially doing is democratizing the technology so that any use case can be addressed with it. And a bit like, what we're now doing. So which that means now is, AI can happen much closer to the human,
Yeah.
right? And that means we're at the sort of very rapid phase of human machine impact, right? When the machine is too far away from the human, we were doing that, and that's what I would characterize the
Yeah.
20, even, pre-23 era. I mean, we're talking like a year, right?
Yeah.
And a half. And is really like you still needed, high tech company to build a model, right? The models were not good enough, you put it into the field, right? You needed all
Yeah.
these kind of things. And now we can build models, in a day with very little effort,
Data. Yeah.
right? And data and effort, data, exactly, data and effort,
Yeah.
um, to take it forward. And that's what I really see the foundation model, doing. And in the sense that it allows people to build on top of it very rapidly.
No, and that's interesting, right? And in fact, sometimes I think that, you know, and at CARPL also, right, we have like kind of this dissonance in our head always, right? Like, is there going to be a day when radiologists are building their own AI, right? Like, you literally you take like a screenshot and you copy and paste it somewhere, and you're like, hey, this is what
Yeah,
demyelination looks like, or something like that. And it's like literally like you're training a person. Sham, I'm gonna, take a few questions. We've got a
yeah.
couple of questions come in. The first is from Dr. John Cruz, who, we both know and respect a lot. Does access to training data for imaging evaluation differentiate RadNet from big iron manufacturers?
First of all, hi, Dr. Cruz. Thanks for
Yeah.
joining. It differentiates RadNet. I think but there people have access to data. I think what differentiates an environment like RadNet is not the data, but is the live environment, right? Is the training environment, is the feedback environment, is the use case environment, right? So I think the ability to take a model, put it into the field, get feedback, and realize that's not the right use case, or oh, it's missing this, this, and this consistently. Now I can fine tune it around that use case, right? I think that's what really differentiates RadNet, or let's say any kind of provider that has a scaled a scaled environment, and an environment where a system can be put in, that we can leverage that closed loop. And Vidur and Dr. Cruz, that's what I think is the future evolution of this business. Is we're going to go from a interpretation platform, which is historically like, PACS, if you will,
PACS. Yeah.
which is much more like a digitization platform, to a human machine interface, which is a learning interpretive system, right? And that's where I think we have an edge, which is how do you build technology when you put it into a interpretive, system, where we have uh, folks like Dr. Cruz giving feedback on the algorithm. It's not actually building that algorithm. That's not the special sauce. The special sauce is building the system
Yeah.
to do that, if you will. And it kind of leads directly to why we're working together,
Yeah.
right?
Yeah.
Is because we both
I didn't even have to do the shameless self-promotion. It just happens.
yeah, because I think we both believe in this sort of, AI control system, interpretive closed loop, which is what I think is the future, of the, radiology interpretation system, right? Going from PACS to to this sort of closed loop system. So I'm quite excited about, and this goes back to the big company, small company thing. How can we really change the industry, right? You and your team and your family in general has been, trying to drive radiology, forward, and so have we. And I think it's a great time to sort of really build these partnerships, how we can really take the next level, right? And that's why I'm really
Yeah.
excited about what we're going to be able to do
No, for
next.
sure, and even for like the independent AI developers out there, like even for them having these closed loop systems where, it's like if you're a chest X-ray AI company, like you're part of the loop. If you're a, chest CT AI company, you're part of the loop. And, it's like, it's not actually just a internal loop. It's, whatever API you could loop in, right? Is,
Well, but this is exactly right. So we
yeah,
have a partner that we've been talking to, which is, most of these AIs, you take your image and you hit the API, you give them the
yeah,
image, and they give you the results back, and then you
yeah,
put it, you show it to people like Dr. Cruz and say, here's the,
yeah,
lumbar spine measurement. What now we're having a discussion is, well, is there an API back when Dr. Cruz says, oh, that's wrong? We
yeah,
feed that back,
yeah,
right? So this
yeah,
is the next, this is really how we really are going to get the scale, right?
yeah,
Is we need that feedback back, whether it's within a system or even the feedback is open,
yeah,
right? It goes back to the AI developer, so
yeah,
that we can build these learning systems as a
yeah.
community, right? Not
Yep.
just kind of in isolation.
Yeah. No, cool. That's amazing. And kind of ties into the next question we have from Girish. Girish Srinivasan. He's a dear friend. I think Girish was at GE for a while. Now he's chief technology officer at a couple of AI companies. So Girish asked, do you see a new breed of organizations that combines intelligent technology embedded closely with hardware in order to take advantage of hardware capabilities? Or do you suggest these two to be independently operating?
Yeah, it's a good question. I think I can answer it in a couple of different ways. I think
So,
the
Sham, I'm going to take the liberty of maybe paraphrasing. If someone was to start a radiology AI company today, should they build a machine plus AI solution, or should they build just the software, right? If,
yeah,
if you were to kind of,
I think we shouldn't. So if we talk about machine, there are multiple machine that you can think about, right? So let's clarify what the machine is. Do I think the future of X-ray is the result is coming directly as you do the scan? Yes.
yes,
Right?
yeah,
Does that mean the machine and the X-ray need to be built together? The X-ray system and the AI
yeah,
need to be built together? No, right? Because they're very different technologies, but two are going to come together in the delivery, right? A little bit like what we're doing in DeepHealth with Smart Mammo, where we've tried
yeah,
to bring the AI closer to the mammo machine, right? Then there's another one, I think, which is maybe where I heard a little bit of the question is, well, what about the machine to make this AI super efficient, right? So that we can do more, things can be done locally, what's done on cloud, et cetera. So that's a great sort of area of innovation. But where we're kind of seeing that happening is we're seeing that happening among the cloud players, right? Among the
mm,
chip manufacturers, where they're now creating, compute technologies that are specifically tuned for this sort of transformer-based, inferencing, transformer-based learning, right? And you see that now where the atomic unit of compute, right? To be running a X-ray, I'll just take something like X-ray, I can guarantee you it will be less than 2 cents or a cent, a US cent,
yeah,
because the companies have now been able to build compute that's tailored, for these kinds of models, right? And more for these sort of types of layered models. So that's already going. I don't necessarily, again, I don't necessarily those companies need to be the same companies as the ones that are doing the software builds, but
yeah.
the people that are building software need to know of both,
But then,
right?
Sham, what is a then how does one create a moat? Like, essentially, if we just take, say, X-ray
Yeah,
or even CT scan, right? Like the architectures are open source, you know
yeah,
how to build a CT, you know how to build an X-ray, right? So
yeah,
anybody theoretically can start building an X-ray tomorrow.
yeah,
Now the same thing is true for AI as well,
yeah,
right? And in fact, like you said, two guys in a garage. I feel like 10th graders can start
yeah,
building world
yeah,
class AI solutions
yeah,
right now, as long as their parents or whoever can get them enough data, or not even
yeah,
enough, like a little bit of data. So
right.
where is the moat?
Yeah, it's a fantastic question. And the reason, and I'm going to take a cop out answer. That's why I'm at RadNet, you know,
Yeah,
because I don't think there is a real distinguishable moat unless you're the end user.
yeah,
And and
yeah.
and and I think that's where um um more and more, and I'm totally agree, because now not only is there, as a healthcare provider, not only do I need two guys in a garage, forget even two guys in a garage, I can go hire a
Yeah,
firm, right? Like a
yeah,
Persistent, a Cognizant, or
yeah,
whoever, and
yeah,
say, I want this built and it's mine.
yeah.
So why do I want to go and, and so that's where I think increasingly that informatics company is getting reimagined what it is, right? You have to kind
But
of
then,
think about,
Sham, if you then, just for the sake of, discussion, if you take that forward, PACS is open source, right? Like,
yeah,
well, almost like if I want, I can just, download like an Orthanc or with a OHIF viewer, and I have my PACS, right? But still there are billion-dollar revenue, like several
yeah.
billion-dollar revenue PACS companies, and then there's this long tail of like 20, 30, 40, 50 customer PACS companies as well. So do you think that is how this will play out? Like there'll be
Well,
like 15, 20 large companies, and then a long tail of
yes,
folks who are doing
yes,
like
because,
ankle MRI and like, you
well, I
know,
think what's going to happen is the AI world is going to fuse very deeply into the traditional PACS world.
hmm,
Then you're going to have the next generation of your interpretive system, right?
hmm,
Because if you're on the way to autonomous, right? PACS is a digitization system. We're
yeah,
missing the semi-autonomous interpretation system, right?
yeah,
And that's the step in between. And it's not going to be moat on technology. It's going to be moat on scale and ability to deliver at scale, right? So we're in
yeah,
an environment, I think it favors, definitely the existing PACS players, because they have the scaled platform, right?
yeah,
And that's the environment we're in, right?
yeah.
And I think the AI players have to start really thinking about how do they integrate to these scaled, delivery systems.
Yeah, I think PACS is distribution, right? Like
Yeah,
it's
yeah,
already there, it works, users love it, so that's
exactly.
that's the moat. Right? Like if users love you,
Exactly.
and if users are like unwilling to kind of let go of you,
Yeah.
that's possibly the strongest
And
moat.
the change curve is very high, right?
Yeah.
Um, and so until you have the change curve really adapt, I think you're still kind of in that world,
Yeah.
right?
We've got one question comment come in from Monit Jadhav. Monit says that intimacy of AI with AI acquisition is something we will see soon, as I see it, called Edge AI. It will be helpful. The CI/CD usage in literal sense should be what I was proposing in Chiron. This is the Mammo company, right? Where as we do image analysis, provide an output, we use it at the same time to send the model to upgrade itself. Okay, so the whole closed loop
Yeah,
system.
yeah,
Incidentally, it was RadNet which was being proposed at that time too for storing these images. Where do we see models of pathology, radiology, and genomics being combined for precision diagnostics for a specific patient, as this is what patients want, and not one model to tell the rad, another to tell the pathologist, and then another for genomics. I'm assuming gen is genomics.
yeah.
Multimodal models are key, and longitudinal data learning is key for a single model to work on for everyone.
Yeah.
So,
I,
yeah,
I
your
you
thoughts
know,
on
I think
RadPath?
it's a good thought, but I think it's sort of a um, use case that is very specific. I don't want to say narrow, but it's very specific. Rad path. I mean, the number of patients you have path on is 2 orders of magnitude, maybe three
Yeah.
orders of magnitude less than imaging. So the notion that these things don't happen independently is not healthcare today, right?
Yeah.
Because imaging is first line, diagnostic, right? A lab is a first line diagnostic. Pathology is not a first line diagnostic, right?
Yeah.
It's third, fourth line diagnostic, right? Genetics, unless you're doing genetics up front, hereditary genetics, right? It's emerging to be more, let's say, second line, right? But then if you're doing genetics on the pathology, you're now at third line, fourth line diagnostic,
Yeah.
right? So we have to be careful when we say everything is about multimodality, because the world is, still very much in, non-invasive diagnostics, right? Which is where imaging and lab and, so I see that axis. So I don't disagree with multimodality, but I think the axis between clinical information, lab, and imaging is actually much more integrative in what we do, let's say what we do in outpatient imaging, than imaging pathology genetics, right?
Yeah.
That's super important in oncology, don't get me wrong, but that's a very
Yeah.
specific area.
No, I think, the way to, at least the framework, I think, is, what are the easiest thing you'd rather automate away,
Yeah,
and, get the experts to spend maybe more time on the more difficult things. Or you can just do more of the difficult thing, even if you're not spending more time on it. And thereby, kind of go from easy to difficult as opposed to, most difficult to, and
yeah.
try
I
to
mean, look,
combine those.
the whole notion of integrating diagnostics, it is a very clear vector in the future.
Yeah.
It doesn't
Yeah.
mean providing AI for the sub area is not important. It just means
Yeah.
it's and, you know,
Yeah.
yeah.
Cool. Awesome. No, thank you, Sham. We're at time. And this was awesome. I know, we can keep talking for hours. And but thank you once again for doing this. Thank you to everybody who joined. And we'll see you next week, same time, same place. Great. Thank you, Sham. Thanks.
Vidur, appreciate it. Good discussion. Yeah. Take
Thank
care.
you.